Hello guys, welcome once more to class online. I am Tutodami. In this edition, if you ever have problem with Newton's law of universal gravitation, you will have a lot of help from this video. We have dealt with many aspects of physics that many students find difficult, and we have simplified. Remember, we deal with Waec and we are more than Waec. Now let's go to question number 41 to number 45. It says a battery of EMF 2 volts is connected to 3 resistors P, Q, and R as illustrated in the diagram above. Determine the voltage across the resistor Q. Okay, now what is the voltage across this setup? Now we are trying to find the voltage across resistor Q, right? Now you can see that Q and P and Q are in what? They are in parallel, right? You can see that they are in parallel. Side P and Q are in parallel, while R is in series. That means it is straight, while P and Q are up and down. That's their parallel. So now we are trying to find the voltage now, but the ultimate voltage is 24 volts, right? Then the voltage at the battery or the cell is 24 volts. Then we have to find the voltage passing through this point and this point. There is something called 14 volts here. Can you notice this? There's 14 volts, but it was not stated in the question, but it's in the drawing. That's why one should observe drawing very, very well. Now you can see here is 24 volts. They mentioned it in the question, but the 14 volt was not mentioned in the question. But the 14 volt is part of that which is in series. Okay. Now you must not forget that EMF is actually a combination of voltage, but it is actually the voltage at the cell, and that means it is the amount of work done between the terminals of a cell. So now I have to find EMF, I would say it is voltage of the one in series plus the voltage of the one in parallel. Now, the summation of the voltage of the one in series voltage is 14 volts, and the total EMF is 24 at the cell, right? So now I have 14 and 24. Then the one in parallel, this voltage P is under the parallel. I don't know. So I'll forever find the voltage at parallel. So I'll move this 4 over to this side to give me voltage parallel equals 24 minus 4, and that's 10 volts. So the total voltage at this parallel point is 10 volts. Now, and the voltage at anything parallel, for anything parallel, the total voltage is the same. So if the total voltage is 24, for each of the resistors or the system, for each of the resistors in that system, the voltage will be the same, and that means the voltage at P will be the same as the voltage at Q. Since the total voltage at the parallel is 10 volts, so they will share the 10, and that will become 10 volts and 10 volts, and that is the answer. The answer is therefore 10 volts. Don't forget that total voltage for anything parallel is the same, but if it is series, you will still need to add up. You will need to plus them, but for parallel, they have the same voltage, and that is what I did here to answer. EMF is equal to voltage series plus voltage parallel. I just minus the series from the EMF, and I got the total voltage for parallel is 10 volts, and then I shared 10, and that is my answer for P. 10 volts. Easy peasy, right? Now let's talk about Newton's law of universal gravitation question. I love this question so much. Let's see. The mass of the earth is 6 times 10 per 24 grams, and that of the room is 7 times 10 per 22 grams. If the distance between them is 4 times 10 per 8 meters, calculate the force of attraction between them. G, or the gravitational constant, is 6.7 times 10 per minus 11 Newton meter square per kilogram square. Now let's check this out now. Now don't forget that the ultimate formula for anything universal gravitation is very simple. It is just F equals Gm1 m2 over r squared, and that can even help you to state the Newton's law of universal gravitation in case you are asked in theory. The Newton law of universal gravitation is directly state that the force or the gravitational force is directly proportional to the product of the mass m1, m2, and inversely proportional, that's over, to the square of the distance apart. Let me come again. If you were asked to state the Newton's law of universal gravitation, just say force or gravitational force is directly proportional. Don't mention this G. It is part of the directly proportional. Force is directly proportional to the product. Why product? Because it is times. Force is directly proportional to the product of the mass m1, m2, and inversely proportional, that's over, to the square of the distance r apart. And that is Newton's law of universal gravitation. Now you have been given the two masses, first one, second mass, M1. This is my M1, and my 7.10 to the power 22 is my M2. Then I have a distance, that's my R, 4 times 10 to the power 8 meter. Then my G is 6.7. Everything is already there. So just plug them in. So my G is 6.7 times 10 to the power minus 11 from the question. Then my M1, the first mass, is 6 times 10 to the power 24. M2 is 7 times 10 to the power 22 from the question, over my R, that's my distance, is 4 times 10 to the power 8. But it has a square in the formula, square. So put a square, and then we'll now solve. Now the next thing is to simplify. 10 to the power 4 times 10 to the power 8 bracket squared. This square will come into the 4. It will become 16. That's 4 squared 16. That's 4 times 4. Then 10 to the power 8 times 2 is 10 to the power 16. Then put the numbers on top all together. 6.7 times number 6 times number 7. Then put all the 10 all together. 10 to the power minus 11 plus 24 plus 22. And that is what I have here. Next, I have 6.7 times 6 times 7 is 281.4 times 10 to the power 35 over 16 times 10 to the power 16, right? 16 times 10 to the power 16. Then that's what I have. Then next thing, divide numbers and numbers. 281.4 divided by 16, that's 17.59 times 10 to the power 35 divided by 10 to the power 6. According to the law of indices, it will become division of power is minus. It will become 10 to the power 35 minus 16, and that will give me 7.59 times 10 to the power 19. You can also summarize your answer approximately as 18, because 5 will round up. It will become 18 times 10 to the power 19. Since you moved, I can move this point this way. It will give me 1.8, approximately 1.8, because 5 will round up to 8, and if you move the point this way, it will give you 1.8 times 10 to the power. Because we have moved the point once, this 10 to the power 19 will become plus 1. It will become 10 to the power 20. So I have 1.8 times 10 to the power 20 Newton as my answer. 1.8 times 10 to the power Newton as my answer. Now the most important part of this question is just that formula. F equals G M1 M2 over R squared, where F is my gravitational force, my G is my gravitational constant, and my M1 is my mass 1, M2 is mass 2, and R is my distance apart. It is just the Newton's law of universal gravitation, and this is the simple formula for any question in physics on it. Now that is the way we simplify it. Now that makes the answer for this one D. Number 43, the angle which the direction of the Earth's magnetic field make with the horizontal at a place is known as what? Now, there are two angles we were taught under the topic magnetism. We were taught angle of declination, and we were taught angle of dip. Now, actually, angle of dip is the angle of inclination also. So you can say angle of inclination, and you can say angle of declination, or angle of inclination or angle of dip. You are saying the same thing. Now you must know what is angle of dip and angle of declination. Now first of all, let's check them out. Angle of dip is the angle in the vertical plane aligned with the magnetic north, the magnetic meridian between the local magnetic field and the horizontal. Now this is the angle of dip here. The magnetic north and the horizontal, the angle between the horizontal, and the magnetic north is called the angle of dip, and that is the angle of dip. Now, but the angle, now let's now check out what is the angle of declination. Is the angle between the magnetic and geographical meridian, or the angle in the horizontal plane between the magnetic north and the true north. Okay, now let's see this out. Now, in the magnet, the north of a magnet is not like the normal north. We have true north. True north points upward. Magnetic north points this way. The angle between the true north of the world and the north of a magnet is called the angle of declination. It is simply the angle between the true north of the earth and the magnetic north is called the angle of declination. Now, the angle of dip is the angle between the horizontal. This is the word horizontal. Okay, is the angle between the horizontal plane and the magnetic field. That means the angle between the vertical plane aligned with the magnetic meridian. That's the magnetic north, and the horizontal plane. Now, if this is the word horizontal, now this my hand is horizontal, is standing horizontal. Now, the magnetic north is where? This way. Now, the angle between the magnetic north and the horizontal, this angle in between these two, the angle between this point and this point is the angle of dip. So, why this is the angle of inclination? This is the word north and the magnetic north. So the angle between the true north and the magnetic north is the angle of declination. That's clear, right? Now the angle of dip is the angle between the horizontal and the magnetic north, or the magnetic meridian. Is the same thing, and that is the angle of dip. And that is the answer to that question. The answer is angle of dip because it is the angle between the direction of the Earth's magnetic field made with the horizontal. So if it is horizontal, it is angle of dip. Please don't forget, because I have seen that many theory questions ask for these two things: angle of dip and angle of declination. And they will just say, draw it and then explain it, define it. So if you cannot define it, you can't even draw it. So it is the angle of dip that is the answer to number 43. Let's check out the number 44. What must be connected between the point P and Q to establish a steady current through the incomplete circuit diagram illustrated above? Now, what does this drawing need to be complete? What will you put here? Every circuit needs one thing, needs something. One, wire. Two, this one has a resistor. There's something taking light. Like in most cases, when I was in basic 5, I was taught that every circuit needs wire, bulb, and the last thing is the answer to this question. It is not a complete circuit without the last thing. You need wire, you need a light taker or something taking the light or taking the charge. Then you need one last thing, and that thing is the light source, and that thing is the battery or the cell. And the answer to that question is just the cell. It is not complete without the cell. So this thing is not complete because there is no cell diagram. And this is the drawing of cell. It's like 1, 1. It's like you write number was 11, but one is long, one is short. So that's it. It needs a cell. So actually, every cell can have ammeter, voltmeter, resistance, and this is the wire. But every cell is not complete. So every circuit, is not complete without a cell. It needs a battery or a source, a light source, and that is the answer. This thing is not complete because it has no cell. So the cell is the answer to the question. Let's check out number 45, the last one. When current flows through a moving coil galvanometer, the force exerted on the pointer depends on what? Now, galvanometer depends on what? When current flows through a moving coil galvanometer, the force depends on what? Now, we must know that. Let's check it out. One, the principle current carrying coil placed in a normal magnetic field experiences a torque, which is given by the formula T, that's torque, equals N IAB, where my N is what? Number of turns, current, area, and of course, magnetic field. So now these are the factors affecting the current moving through a galvanometer: number of turns, area of coil, magnetic field. A galvanometer cannot be used to measure the current because all the currents. Okay, but I have gotten what I need. It's just the factors affecting, and they have to do with the formula for finding torque. Okay, now torque is equal to number of turns times the current times the area times the magnetic field, and those ones in the formula are the factors affecting a galvanometer. So it is number of turns. Let's check it out. We have strength of the current. Did they mention current? Yes. Then did they mention magnetic field strength? Yes. The magnetic field also affect. Then did they mention what else? Length of the coil. Did they mention length of the coil? Yes, that's the area of the coil. So the factor affecting it is just all of them. So it is the strength of the current, the magnetic field strength, and the length of the coil. They all affect a galvanometer, and those are the factors affecting galvanometer. The strength of the current affect. When you are performing experiment, you use galvanometer, right? That if you are doing electrical experiment, you need to use a galvanometer. So you can't use it without using current, and without testing the magnetic field and the coil also. In the case of a moving coil experiment, if you are working with coil, with an experiment that has to do with coil, you will have to use all this stuff. And these are the factors that affect how the galvanometer works. And that brings us to the answer as D. And that brings us to the end of this session. Don't forget, if you learned something from this video and you want more content to be sent to you that will better help you understand physics, click on the like button and we'll get to reach you with more content that will better help you understand. Until we see you again, guys, take care of yourself and bye for now.